So imagine you're holding this huge stack of papers, like a really dense 61-page manifesto.
Okay, yeah. Sounds like a pretty heavy read.
Oh, it is. And you flip to the very first page, right? And sitting right there in the opening paragraph is this claim that is just so massive, it almost feels like a provocation.
Let me guess. They solved the universe.
Basically, the author straight up says that modern physics, the fundamental bedrock laid down by Albert Einstein has been completely misunderstanding how the universe works for over a century.
Wow. I mean, claims of that magnitude, they usually end up in a very specific, let's call it a discard pile on a physicist's desk.
Right, exactly.
Because the scientific community is just so deeply entrenched in these established relativistic models. When someone hands you a paper declaring Einstein was wrong, the natural instinct is just to say, this is fringe theory, and you move on.
Yeah, but see, dropping this specific stack of papers in the recycling bin would be a massive mistake.
Really? Why is that?
Because what makes the source material for today's deep dive into the sources so fascinating isn't just the audacity of the claim, it's the methodology.
Okay, I'm intrigued. What did they do?
So the author is this Japanese blogger who publishes under the handle Zionod 2023. And on March 23rd, 2026, they finalized this 61-page thesis.
Which is provocatively titled, if I recall, Draft Einstein Slack Off 137.
Yes, exactly. Draft Einstein Slack Off 137. And instead of, submitting it to a traditional academic journal where it would just get torn apart by human reviewers, they did something incredibly modern.
They bypassed the humans entirely.
Totally. They fed the entire complex document to 4 distinct cutting-edge AI models. We're talking Google AI Studio, ChatGPT, Claude, and Gemini.
Which is just a fascinating approach. They essentially weaponized artificial intelligence to act as this high-level, brutally objective peer review panel.
Right. And they didn't just ask the models for, like, a polite summary or to fix their typos.
No. They engineered the prompts specifically to force these AIs to hunt for logical inconsistencies, to find mathematical errors and structural flaws in their physics.
And this is the best part. Zionad 2023 just published the raw transcripts of these interactions, all of it.
The good, the bad, and the ugly.
Exactly. The debates, the validations, the really fierce pushbacks. So our mission in today's deep dive is to explore this incredible collision.
It really is a collision. You've got human theoretical physics trying to break the boundaries of the known universe using AI as the ultimate sounding board.
Yeah. And I want to emphasize for everyone listening, you absolutely do not need a PhD in astrophysics to appreciate the drama of this intellectual battle.
Oh, definitely not. But to understand the battle playing out in those AI transcripts, we do have to unpack the author's core critique first.
Okay, let's unpack this. What exactly is their problem with Einstein?
Right, so we have to look at why Zionad 2023 believes Einstein's model of special relativity is just fundamentally flawed. The entire manifesto really targets something physicists call the Cartesian coordinate origin.
Which is basically the 0, 0, 0 starting point on a graph, right?
Exactly. Modern physics anchors its mathematical models to the observer's coordinate origin. It assumes that the vantage point of the observer is the absolute baseline for reality.
But the author is saying that's a mistake.
A catastrophic mistake, mathematically and philosophically. They argue that treating this localized vantage point as objective reality is, well, an illusion. They actually call it the camera eye illusion.
A camera eye illusion. That is such a vivid way to put it.
It really perfectly captures the critique. The author posits that the Cartesian origin is not objective reality at all. It's just this highly localized, deeply limited viewpoint that is entirely compromised by the speed of light.
Because light has a speed limit. It's fast, but it still takes time to get from point A and point B.
Precisely. Because light takes time to travel from an object to an observer, every single thing that camera eye processes is technically an event that has already happened. It's in the past.
Okay, let me try to map this onto something we deal with every day, because I think I have a good analogy for this.
Go for it.
Consider watching a live sports stream, right? But you're on a terribly slow, just awful internet connection.
Oh, the worst.
Yeah. So the players on your screen, they start lagging. They freeze for a second, the frame rate totally drops, and then suddenly the striker just jumps 10 feet across the field and scores a goal.
Right, a massive glitch.
But the lag isn't actually happening in the physical stadium. The players aren't literally teleporting or moving in slow motion on the actual grass.
Oh, of course not.
It is purely a bug in how the information is being transmitted and rendered on your specific screen, your camera eye.
That visualizes the author's argument beautifully. The author claims that a century ago, early theoretical physicists looked at the cosmic equivalent of that internet lag and erroneously assumed the actual stadium was stretching and warping.
Wow. So they thought the glitch was real physics.
Exactly. Which brings us to Lorentz contraction.
Right, the idea that objects squish when they go really fast.
Yeah. When an object moves incredibly fast, like approaching the speed of light, the equations of special relativity show that the object physically squishes or contracts along the direction it's moving.
But the author looks at that totally established science and boldly calls it a myth.
A complete myth. They describe Lorentz contraction as a mere patchwork.
A patchwork, that's a strong word.
It is. They're saying it's a mathematical cover-up designed to hide the visual bug caused by the information delay of light. They genuinely believe physicists built a model where the stadium itself is shrinking because they failed to realize it was just the delay in the light reaching the camera eye.
That is wild. So if the current model is just a patchwork, what's their fix? I mean, how do they propose we get rid of the glitch?
Well, transitioning away from that flawed framework requires a radical new model. The author insists we have to abandon what they colorfully describe as our meat position.
Okay, wait. Meat position.
Yeah, the meat position.
That is a brutally visceral way to describe being trapped in our own biology.
It really is. We are anchored to our physical senses, right? We rely on actual photons hitting our physical retinas to tell us what time it is and where things are.
So to escape this meat position, what do we do?
The author proposes a purely mathematical solution, shifting the entire universe onto a global coordinate system using what they call complex space.
Complex space, meaning what exactly?
Instead of anchoring the universe to a single observer's delayed perception, they introduce this mathematical framework designed to strip the delay out entirely.
Okay, and we actually have visual aids for this in the source material, right? These elaborate hand-drawn diagrams trying to map this escape.
Yes, the sketches are fascinating.
They draw these purple rectangular objects, which I guess are meant to be high-speed trains or airplanes traveling along a flat axis.
Right, moving left to right.
Yeah, and they sketch the object's position at time 0 and then again at time 10. And below this, there are these deliberate downward arrows pointing to a circular node labeled the camera eye.
And those sketches represent the author's mathematical attempt to literally peel off the information delay.
Peel it off, like removing a filter.
Exactly. They're visually separating where the train actually is in the physical world from where the camera eye perceives it to be, based on the arrival of those delayed light signals.
So how does the math actually work for that?
Well, the math involves taking the perceived position, calculating the distance to the observer, dividing that by the speed of light, and then subtracting that specific time fraction to find the true underlying coordinate.
Okay, let's unpack this a bit more. What is the ultimate payoff here? If they successfully execute that math, if they manage to peel back the lag of the universe's Wi-Fi for every single object in motion, what do we get?
The ultimate payoff is something the author calls public space and public time.
Public time, like a universal clock.
Exactly. A clock that ticks at the exact same rate for every single entity in the universe, regardless of whether they're sitting completely still on Earth or rocketing through a nebula at half the speed of light.
So an absolute, perfectly synchronized reality.
Yes. It is an incredibly elegant and frankly philosophically comforting idea. This notion that beneath the messy, delayed perceptions of our camera eyes, there is a shared objective now.
That does sound comforting. And this is the exact moment in the narrative where the author feeds this beautiful, complex system to the AI models, right? To see if it actually holds up under the weight of computational logic.
That's right. And the initial results must have felt like a massive victory for them.
Because Google AI Studio and Gemini were the first ones up.
And their responses were almost shockingly positive.
Yeah, AI Studio essentially adopted the persona of this enthusiastic academic mentor.
It really did. It processed the entire 61 pages, analyzed the proposed shift from local observation to global coordinates, and it just validated the core premise.
It actually used the phrase paradigm shift in modern physics.
Which is huge, coming from an advanced AI.
Right. And it went beyond just validation. It offered structural advice for publishing. Like AI Studio highlighted those hand-drawn diagrams of the airplanes, suggesting the author feature them prominently.
Because they perfectly illustrate that mechanism of peeling off the information delay.
Exactly. And then Gemini followed suit with this highly objective, really tight structural summary.
Yet Gemini tracked the logical flow of the equations. It noted how the author repurposed the Lorentz equation, not as a physical warping of space, but as a geometric correction designed to reveal that hidden public space.
So the AIs were basically cheerleaders at this point.
They were, which tells us something really vital about how these specific large language models operate.
What do you mean?
Gemini and AI Studio were evaluating the internal consistency of the author's axiomatic system. They looked at the rules the author established, followed the math, and confirmed that if A equals B, then C naturally follows.
So the internal structure was completely sound.
Totally sound.
Okay, so Gemini and AI Studio proved that the author's math is internally flawless.
Right.
But internal logic does not equal physical reality, right? I mean, you can build a perfectly logical mathematical system describing a universe made entirely of Swiss cheese.
Yeah.
And the math might check out perfectly, but it doesn't mean the actual universe is made of dairy.
That is a perfect way to put it.
Yeah.
And that conceptual friction is exactly where ChatGPT violently broke rank with the other models.
Oh man, ChatGPT did not hold back.
It really didn't.
Mm-hmm.
ChatGPT evaluated the actual physical implications of the physics and delivered this profound reality check.
It essentially told the author, look, your direction is mathematically coherent, but your physical conclusion is a massive leap.
Right. ChatGPT zeroed in on the true nature of the Lorentz transformation. It pointed out that in the real universe, it is not merely a visual correction formula.
It's an actual structural thing.
Yes. ChatGPT explained that it represents an actual hyperbolic rotation in Minkowski spacetime.
Okay, wait. I'm still stuck on this. Let me push back on ChatGPT's conclusion for a second here.
Sure, go ahead.
If everything we observe is fundamentally filtered through light, right?
Right.
And light has a strict speed limit.
Yes.
Why wouldn't mathematically removing that speed limit reveal the true simultaneous universe? I mean, if I perfectly calculate the lag and subtract it, why wouldn't I find public time? Why is ChatGPT so absolutely sure that mathematically fixing the optical illusion doesn't solve the problem?
What's fascinating here is that to understand why ChatGPT dismisses public time, we have to look at how Minkowski spacetime actually functions.
Okay, I'm ready.
Imagine the universe, all of space and all of time, as a giant solid loaf of bread.
Okay, a cosmic loaf of bread. I'm with you.
When you are standing completely still, you experience the present moment by cutting a slice of that bread perfectly straight down.
So a vertical slice.
Exactly. Everything in that specific slice represents your now. Every event on that slice is happening simultaneously for you.
So my slice includes me sitting here right now, maybe a star exploding in the Andromeda galaxy, and a comet hitting a moon somewhere else, all happening at the exact same moment.
Yes, exactly.
Yeah.
But the moment you start moving, say you get in a spaceship and travel at high speed,
Yeah.
you don't just change your position in space.
What else changes?
Your velocity literally changes the angle at which you slice the bread. This is what ChatGPT meant by hyperbolic rotation.
Oh, wow. So my slice of now tilts.
Exactly. It tilts. It might tilt forward into what a stationary person considers the future, or tilt backward into what they consider the past.
Meaning my now and your now contain completely different physical events.
Fundamentally different events. And it has absolutely nothing to do with the time it takes light to reach your eyes.
Wait, really? Nothing to do with the light delay?
Nothing. Even if you possessed godlike computational powers and instantly removed all information delay from the universe, your tilted slice of bread still would not match my straight slice of bread.
That is mind-blowing.
Because simultaneity itself is relative.
Yeah.
The very fabric of reality is woven in such a way that the absolute public time the author is frantically searching for simply does not exist to be found.
It's structurally absent from the universe.
Exactly.
That is a staggering realization. ChatGPT dismantled the idea by proving the math was trying to solve a problem that wasn't an illusion at all. It was the fundamental architecture of reality.
Yeah, it was a pretty harsh reality check for the manifesto.
But the critique doesn't end there, does it? Because Claude enters the debate next and attacks the theory from a completely different angle.
Right. If ChatGPT dismantled the structural physics, Claude dismantled the historical context.
Claude delivered this brilliant piece of historical physics critique.
It did. It analyzed the author's grand solution of a complex global public space and pointed out that this isn't a bold step forward into a new paradigm at all.
It's actually a massive regression.
A total step backward.
Yeah.
Claude recognized that the author's concept of an absolute static background coordinate system is practically identical to a defunct 19th century theory.
A theory called the luminiferous ether.
Yes, the ether.
Okay, so for anyone who doesn't know, Before physicists understood the true nature of a vacuum, they assumed light needed a physical medium to travel through.
Right, much like sound waves require air or water to vibrate through.
Exactly. They theorized the universe was filled with this invisible, perfectly still substance called the ether. It acted as the ultimate, absolute resting frame for the cosmos.
Which is exactly what the author's public space is trying to be.
Right. And the scientific community fully embraced the ether model back then until they actually tried to measure it.
And this is where Claude leaves the author with a devastating, frankly impossible question. If this absolute public space exists, how do you explain the Michelson-Morley experiment?
Ouch. Yeah, which brings us right back to the brick wall of the 1880s.
Yep. So Albert Michelson and Edward Morley designed this highly sensitive instrument called an interferometer.
And the logic they used was simple, right? If the Earth is hurtling through this invisible stationary ether as it orbits the sun, we should be able to detect an ether wind.
Exactly. Just like feeling the wind on your face when you stick your head out of a moving car.
So they fired a beam of light, split it, and sent the two beams bouncing off mirrors at right angles to each other.
Right. And if the ether existed, the beam moving against the ether wind should travel slightly slower than the beam moving across it.
And when the beams recombined, they would be out of phase.
They ran this experiment over and over with increasing precision, fully expecting to map the absolute background of the universe.
And they found absolutely nothing.
Nothing at all.
The speed of light remained completely constant, perfectly identical in every single direction, regardless of how the Earth was moving.
There was no wind. There was no absolute background space.
That famous failed experiment is what eventually forced the scientific community to abandon the ether and accept Einstein's realization that space and time are inextricably linked and entirely relative.
And Claude forces the author to confront this physical data. It's saying, look, you cannot build a pristine mathematical model in a conceptual vacuum.
It has to survive the brutal, messy arena of historical experimental physics.
Right. Claude showed the author that their theory fails an experiment we already ran and verified 140 years ago.
So what does this all mean? The contrast in the feedback across these AI models is just incredible.
It really is night and day.
The author had an intuitive, deeply logical idea. Correcting visual lag makes total sense to our human brains because we deal with it constantly. We see it on our screens. We understand delay.
Yeah, and AI Studio and Gemini looked at that internal logic and gave it a standing ovation.
But then ChatGPT and Claude demonstrated how a flawless, internally consistent logical structure shatters the moment it collides with foundational space-time geometry and hard empirical data.
It serves as a profound reminder of the limits of purely mathematical logic. I mean, you can build an exquisitely flawless universe in your mind, but if it doesn't align with the strange, entirely non-intuitive way our actual universe operates.
Like the literal absence of a universal now?
Exactly. Then it remains a beautiful fiction.
The journey captured in these source files is just mesmerizing. We follow this lone thinker, Zionad 2023, spending 61 pages desperately trying to dismantle Einstein's framework to resurrect a universal public time.
And then they submit their life's work to this artificial intelligence panel, resulting in a fascinating split decision.
The cheerleaders validate the logic, while the heavyweights drop the hammer of hyperbolic geometry and historical reality.
The rigor of the debates in these AI logs represents a deeply modern evolution of how theoretical philosophy and physics can be stress-tested today.
Absolutely. As we wrap up this deep dive into the sources, I want to leave you with a final thought, drawn from the author's wider blog archive.
Oh, this is a good one.
Before they ever fed this manifesto to the AI models, Zionad 2023 published a post with a very simple, very famous title, "The Map is Not the Territory."
They used it to warn physicists not to confuse their localized math with objective reality.
Right. A warning the author felt modern physics had largely ignored.
But consider the implications of that phrase when applied to this entire AI experiment.
Yes. The author sought an ultimate objective truth by turning to artificial intelligence. Yet the AIs themselves proved to be just another set of camera eyes.
They really did. Google AI Studio mapped the prompt through the lens of internal logical consistency.
ChatGPT mapped it through the lens of structural physics.
And Claude mapped it through historical empirical data.
None of them possessed the absolute godlike view of the territory. They were entirely constrained by their distinct training architectures, returning fundamentally different realities based on how they process information.
It suggests that escaping our subjective viewpoints is much harder than just outsourcing the thinking to a machine.
It really does. If we are entering an era where we use AI to validate our most complex theories of reality, we have to remember that the machine's output is not the absolute territory either.
No, it's just another map.
Drawn by a different kind of observer, prone to its own kind of information delay, the absolute objective public space might forever remain out of reach, not just for humans, but for the machines we build to find it. Thank you for joining us on this deep dive. Take care.